In this video, we're going to take a look at proportions, and perhaps a little bit more complex than you've been used to. They're not really harder, they're just more involved. If you haven't done a whole lot with algebra, this is probably not going to be the video for you. The word problem may be very similar to something you've already done. Proportions are used quite a bit out in the real world, really. And that's something that most people should have an understanding about how to work with, because it can help you scale. Whether you need to scale up or scale down, that sort of thing. But it can be quite heavily used in a lot of different fields. So the basic idea behind this, green here I suppose, the basic idea is we want to take a look at the structure. And the structure is nothing more than just a fraction equals another fraction. And the question is, well, when does this occur? It occurs when the cross products are equal, and this is part of the definition of a proportion. That if two fractions are in proportion, then their cross products must also be equal. Now this is a kind of an outcropping of algebra, but prior to algebra and just regular arithmetic to see if two fractions are in fact equal, this is something that you can use before you deal with algebra. So now that we have this kind of in the background, we know what we're going to do. We're just going to multiply both, or cross multiply, and then we're going to end up getting rid of all the denominators. So life is good. Well, the problem here is that if we take a look at the denominators that we currently have, we have issues. You see, there's at a point, one of these denominators, or both of the denominators, might be 0. We can't allow that to happen because we cannot divide by 0. So we're going to take a look at each denominator, 3x, and we're just going to simply make the statement that 3x cannot be 0. Well, if I divide both sides by 3, then that tells me that x itself cannot be 0. Likewise, if 5x can't be 0, if I divide both sides by 5, then x still can't be 0. So we cannot allow our solutions to have an x equal to 0. If it does, it's kind of crap. So we're just going to throw it out. In more proper terms, this is called an extraneous root. It happens when you use, or I should say, when you make an assumption that isn't necessarily true. For example, we're going to multiply both sides by this 3x and 5x, and we're going to, in effect, cross multiply. Now, in algebra, you're not allowed to do that if, in fact, the value of the 5x is 0. If it is, then you're violating one of what usually is learned as the second rule, which is you can multiply both sides of any equation by any non-zero number. And the reason for the non-zero is if you multiply both sides by 0, the whole thing would just go to 0 equals 0, and it's trivial. So, yeah. All right, so we're going to keep this in mind as we move through this, and we're going to multiply or cross multiply, keeping in mind that anything covered by a fraction bar is itself in parentheses, or you can assume it to be. So this is going to give us 5x times x minus 4 is equal to 3x and x minus 2. All right, now just going through and solving this however you wish to do it, and I'm sure that I'll get some complaints that that's not how I was taught. Yeah, I do it like all the different ways because I change my way depending on what I'm given. So anyway, just go ahead and going through distribution, I'm going to get 5x squared, and then minus 20x is equal to 3x squared minus 6x. Now I have x squared terms. The suggestion behind that is that I'm going to have to move everything to one side and make the other side 0 because I'm going to have a quadratic. So I'm going to attempt to do that by subtracting 3x squared from both sides. And in a separate step, or in the current step here, I can just simply add 6x to both sides. Now I'm kind of combining two steps at once, but it's more for speed. So negative 6 plus 6 is 0. That zeroes out that term, eliminating the 6x. And the 3x squared is eliminated by subtracting 3x squared. So I'm left with 2x squared, and then a minus 14x is equal to 0. Now I'm sure that there's 1,000 different ways to go from here. I'm going to choose to divide both sides by 2 because my natural instinct is to reduce as much as I can before I start my processes. That way, if it's going to be nasty, I can kind of reduce some of the nastiness. That's going to give me x squared minus 7x is equal to 0. Now, this next piece is going to probably cause some of you to go, hey, you could have factored out a 2x. You know what? You're right. Why didn't you? Because I didn't want to. That's basically what it comes down to. All right. And I'm probably going to get some hate mail from teachers. I'm trying to teach these kids. I know, but I'm trying to be legal about it. There's no restriction as to the methodology that you use so long as it's algebraically correct. I mean, it's not. Everything else is artificially imposed. So, yeah. So I'm going to factor out an x, leaving me with x minus 7 is equal to 0. And however you might have been taught this, I have two numbers that equal 0. So I have this, and these two numbers multiplied give me 0, which means that one of them must have been 0. Which one? I have no idea. So, or x minus 7 is equal to 0. And I'm sure some of you out there will go, well, what if they're both 0? Well, x can't be two different values at the same time. That's not really allowed. So we're checking one or the other. So here we go. X can is equal to 0. Okay, well, that's fine. No big deal there. Or, notice that x equals 0 is already solved, so we don't have to touch it. Or x minus 7 equals 0. So if I add 7 to both sides, that's going to give me x is equal to 7. Now we have a distinct problem. In the very beginning, we said we cannot allow x to be 0. That's bad. Okay, well here we got a solution of x equals 0. Yeah, the problem there is that we kind of introduced that by the way that we solved the equations. So that's kind of junk and we throw it out. So what's left is x is equal to 7. So that is our only allowable answer, because otherwise our denominators in our original proportion would have been 0. Dividing by 0 is only good if you're in a black hole. So after that, nobody really bothers with it. All right, moving on. Just kind of an example of a well, somewhat a simplified problem, but it really occurs in real life, and those of you in the auto mechanics world should probably recognize this. If you're in Michigan, you're not putting 40%, it's a 50% mixture. But an antifreeze container recommends 4 quarts of antifreeze for every 10 quarts of radiator capacity. So this is going to be a 40% concentration by volume. How much antifreeze would you need if your radiator holds 22 quarts? Now, the way that I recommend to my students to solve these and set these up is that your tops and your bottoms have to agree. And so if I were to put a need in the top and a capacity in the bottom for one type of measurement, let's say for what the antifreeze container recommends, then my other side has to be a need on top and a capacity on the bottom. And then I can just kind of fill in the blank. So from my container, this is going to be, I need 4 for every 10. And then in my car, I need how many? I don't know. All right, well, let's call that X then. And I have a 22 quart capacity. So now I really have this 4 over 10 is equal to X over 22. Now I can just go ahead and cross multiply and solve. Now we don't have a variable on the bottom, so we don't have any values of X that cannot be allowed. So I can just go ahead and cross multiply, giving me 88 is equal to 10x. And then dividing by 10, that just gives me 8.8 is equal to x. So I need 8.8 quarts in this particular concentration in order to refill my radiator. Let's hope I didn't have to do that on purpose, like it blew out or something. Anywho, this is the way it works. This is just the way that all of it works. It works the exact same way every single time. The hint I would give you is that if you use this as kind of a gateway into other types of equations where you might have rational equations, those that have numerators and denominators on both sides, the rule for proportions is that you need one single fraction on each side of the equal sign. So if you're going to use this particular method, you have to have one fraction on each side of the equal sign. So if you've got something like 4 over x plus 3 over 5x equals, that's not one fraction. Those are two fractions. You have to get a common denominator and combine the numerators. I'll have another video that kind of deals with that and what happens there. All right, hope this helps. Take care.